Hi, my name is Surgeon Grover, and this is my report for Lab 4 of Physics 2212. Introduction. The purpose of this lab is to utilize principles of current through loops and wires, looking at and predicting behaviors of circuits with ohms and capacitors, and utilizing multimeters to gather data. The fundamental physics principles for this lab are node and loop rule, conservation of energy and charge, Ohm's law, and steady state currents. The lab's results are I1 and I2 equals 0.0206 ammeters. We're going to be assuming that resistance of ammeter and wire resistance are negligible. So here are the calculations. Our circuit is with 2 ammeters, two 1.5 voltage batteries, and two resistors. The predicted current of I1 and I2 are 0.020241 ammeters. The actual value of I1 and I2 are 0.0206 ammeters. And here the calculations continue done in an Excel sheet. So possible sources of error for this lab are human error reading the measurements, human error in setting the circuit, and old batteries which probably have varying voltage levels. So what if questions? What if we were doing this in a lab in real life and we use an actual ammeter instead of an ideal simulated ammeter? What's different about a real ammeter and how would it affect the circuits you hooked up with? If you did this lab with real circuit components, access the virtual circuit link above and see if you can determine how it behaved differently from the real ammeter used. Because the ammeter would have given no resistance, the current would have been able to flow more freely around the circuit, leading to higher current values, and all calculations would have been more exact. What if we were doing this in real life and we use a real battery to charge a real capacitor with no resistance in the resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. All right. If you were completing a lab with real circuit components, use an ammeter to just measure how long it takes to charge the capacitor with when connect directly to the battery and the ammeter. Discuss why the measured time is different from the predicted time. If there was no resistance and the battery was ideal, the circuit would instantly charge as all voltage could immediately go to the capacitor with nothing stopping the flow.